Hey guys, so today we are going to learn about linearization. So we are given a question like this. So we are given a function f of x and we have to use linearization to approximate f of 82 near x equals 81. So we have to recognize that we have to use the linearization equation, which is L of x equals f of a plus f prime of a times x minus a. So this approximates f of x. So we can say that it's approximately equal to this equation. So we need to find f of a and f prime of a. So that's what we need to do, and then we're going to plug it back into this equation. So in this case, our a is equal to 81. Because we are finding, so this is what we're trying to find, but we will be able to plug in a equals 81 just into the function like that. So our a is 81 because it's near 81. So first we're going to find f of a. So f of a is going to be equal to us just plugging in f of 81 because our a is 81. And then we are going to plug in 81 into our function. So we're just going to replace the x with the 81. So 81 to x 1 over 4 plus 1. 81 is the same as, we could rewrite it as 3 to x 1 4. And then we can add 1 like that. And then we could multiply these exponents together. So we can multiply these exponents together because of exponent loss. And then when we multiply these exponents together, we can cross these off and we get 3 to the exponent 1 plus 1. So that would give us 4. So we got f of a. Now we are going to find f prime of a. So to find f prime of a, we need to find the derivative of the function. So we're going to just find f prime of x first. Let's do that. That will help us. So f prime of x is going to be, we're going to use the power rule for derivatives, so we're going to do that. So we're going to get 1 over 4 times x to x 1 over 4 minus 1, and that is because here we have 1 over 4 as the exponent. We bring it up to the front and we subtract 1 from the exponent. So that's just using the power rule. And then we are going to get 1 over 4 x to x 1 over 4 minus 4 over 4, and that would be equal to 1 over 4 x exponent of negative 3 over 4. And since we have a negative exponent, we can basically put that in the denominator. So we're going to do that and move this x to a denominator, and we're going to make it 3 over 4 now. So we have positive exponents now. Okay, so we got the derivative. Now we have to basically find f prime of a. So f prime of a, remember a is equal to 81. So we are going to find f prime of 81. So f prime of a is equal to f prime of 81. F prime of 81 is going to be equal to basically us plugging in this 81 into the x for this derivative. So we're going to do that. So 1 over 4 times 81 to the exponent of 3 over 4. And we know that 81 is basically equal to 3 to exponent 4. So we're going to rewrite it as such. So this is just basically 81. We're just copying this here, so we're plugging it in. And then we get 1 over 4 times 3 to exponent 4 times 3 over 4, because we can rewrite it because of the exponent loss. And we can cross out these 4's. And once we cross out these 4's, we will get 1 over 4 times 3 to exponent 3, which is the same as 1 over 4 times 27, which is ultimately equal to 1 over 108. So now we got both parts. We got f prime of a and we got f of a. So now we are going to plug these in to the equation for linearization. So to do that, we are just going to recognize this is the equation. So right here, it is shown that f of a is equal to 4. And it is shown that f prime of a is equal to 1 over 108. So we're going to plug those two in. So we're going to write f of a is equal to 4. So we replace this f of a with 4 plus f prime of a, which is 1 over 108, which was shown right here. And then we have to write x minus a. But remember, a is equal to 81, so we're going to write x minus 81 instead. And we are trying to approximate this at x equals 82. So f of 82 we're trying to find. So we are going to write down, we're going to basically plug in x equals 82 in here. And we are going to plug it into the other x. And we are going to get 4 plus 1 over 108 times 1, which is equal to 4 plus 1 over 108. And if you plug this into your calculator, you will get approximately 4.009259,259. So we can basically conclude that f of 82 is equal approximately to L of 82, which is basically the same as saying it's equal approximately to 4.009259,259. Now, this is basically what we were hoping to find, and to check our work for this question, all we have to do is actually find f of 82. So we're just going to plug in f of 82 into the original function, which is x exponent 1 over 4 plus 1. So we're going to check our work like that. So to check our work, we are going to do that. So if we do f of 82, we will get 82 to exponent 1 over 4 plus 1. And you will get approximately 4.00921669. So it's quite close to the value we found at the bottom here, 4.009259,259. So this shows that our linearization question is done correctly because it is very close to f of 82.